Hi everyone, my name is Christian Hill, and I'm a computer science student at the University of Colorado Boulder. And my project for this conference is the Electronette. It's an HDI device for tactile interaction with the human arm, and also for muscle contractions using electrical stimuli. So a little introduction about my background. I've worked in the same lab for about a year and a half now, and I specialize in both tactile devices and sensory extension and sensory augmentation. So just to briefly explain what tactile devices are, if you receive like a notification to your phone and your phone vibrates and you feel it on your skin, that's a tactile device. So basically with this device, it's able to take in an input and give you a tactile output. But it's also, my main goal for this was to map muscle impulses or muscle memory onto hardware. So my main inspiration was I wanted to be able to pick up an instrument and play it without reading any sheet music, knowing any of the finger positionings and stuff like that. So a little bit of background. So our body is actually a really bad conductor for electricity. So for example, I have this 9-volt alkaline battery right here. And so placing my finger across the top using Ohm's law, I'm only getting about 900 microamps, which is completely undetectable. But one part of your body that is a good conductor is your tongue, which I think you want to lick a battery, correct? So yeah, come on, we'll both lick it together. Does anyone else want to lick a battery? I have an infinite amount. So yeah, okay, so we're both going to lick it, and that's going to be around the 1 to 5 milliamps, which is going to be the tingling sensation. So go ahead and do it. So it's tingling, right? Yeah. Okay. I'll say that. So yeah. So for the tactile use I mentioned before, we're going to be running that from 5 to 10 milliamps. And for the muscle contractions, 10 to 20 milliamps. If you guys stopped by and tested out the machine yesterday, I was actually running at about 25 to 30, just because that's what I'm comfortable with. That's what I like. Which, that seems kind of contradictory to the next point, which is 20 to 21 plus milliamps is process and depth. But that's mostly because of misplacement with the electrodes down here, which are these pads down here. So if you put anything above maybe 21 milliamps anywhere across your body, maybe one in the front, one in the back, you're going to end up causing yourself to have a heart attack or some sort of heart failure, especially if you have a pacemaker. So why the Electronette? The Electronette, as you might know, it's not a real word. It's a combination of two words. So it's a combination of electrodes, which are those little circular things I showed you, and marionette. Because when you have all the strings on your body, you kind of look like a marionette, and I'm able to control you. So the Electronette, as I said before, can be used as a standard tactile output device for simple applications. Also rapid prototyping for building these applications as well. And then it can also be used to control a multitude of muscles in the body. Currently, I'm able to control every single finger in both my hands, as well as some basic movements such as up and down with the forearm, and some up and down with the arm movement. And so how the Electronette works. So we take a EMS unit or other DC electrical source, and we separate that into two channels. So one channel is going to be the positive, or the DCC. The other side is going to be the ground, or the negative. And then those are further put into, those are further put into the relays, into the COM port of the relays, which allows me to control them using an Arduino, which I program in C. And so this current device allows up to 32 electrode connections, which I have not found a purpose for all 32 quite yet. And so here are the findings and applications. So first we'll start with the middle one right there. So the middle one is all the patches on my arm that allow me to control each individual finger. And I think currently that's around 12, I believe. So 12 on both arms. I'm just getting 24 electrodes, which is well under the maximum capacity. And then one of the issues as well is when you are trying to place electrodes, and if you stop by my booth, my poster yesterday, you probably noticed that I wasn't able to really control individual fingers on you, just because of the placement is very difficult. So I'm trying to work on a sleeve that people are able to put on their arm that will automatically connect to those muscle groups in your arm. So next, here's me controlling each of my individual fingers. And there, I did a little bit too much voltage on that finger, as you can tell. And there's that. And so the next video is you have extensors, so I'm able to open your hand as well in all your fingers. And then this is moving the bicep. And we actually get pretty decent movement as well. So it's not just like I'm completely at capacity raising it straight up. I'm able to, adjust it a little bit. And then, yeah. Yeah, sorry about that. And then, yeah, here's the beginning of learning how to play an instrument. Yeah, so it isn't exactly music yet, but we're able to play notes, which is, it's a step, right? All right, so future research. So I want to use this as a visual rehabilitation device for people who have recently had strokes. Just because from previous research, maybe some of you have heard of like the mirror type research used for patients who've had strokes to gain further ability in their movement in their hands. So I'd like to do that. And then the step above that would be actually using this to control their hand. Just so if maybe they aren't able to have, or gain a certain amount of movement, this device would hopefully be able to supplement. And so next is the finger placement for music and sports. So for the music side, I'm currently working on a silent piano for people who are deaf. So this would be a tactile use for the Electronette. It's that each key would be individually mapped onto a part of your body. So a person who is deaf would be able to feel the different keys in the keyboard. And then the other music, as you saw, I'm trying to learn how to play a recorder as well. And then from there, I would like to step up to the trumpet. So, yeah. And so next is for sports. So I'm a big fan of baseball. I grew up playing baseball. And I always wanted to be a pitcher, but I never knew how to place my hands for specific pitches. So with this device, I'm able to control certain fingers and able to get the correct placement of baseballs as well. And so that's something that I'm very interested in pursuing further, but I really want to focus on the rehabilitation aspect right now. And then use as a tactile output device. Currently, that's just kind of me playing around. So like I have a little miniature cat that I pet, and I can feel me petting it across my arm. The hand down there is another tactile output device. Also working on just other various fun things. I'm planning on uploading the schematics and step-by-step instructions on how to build one of these, just so I can get it to younger, developers and students and other graduates so they can continue on the application building process. So there are my references. I'd like to say thank you to Mike and Ann, who are my mentors. They're married, so it's a very family-friendly lab environment. My testers and video volunteers, Angelique Cody, who is also another McNair scholar, but she wasn't able to make it here, and Rona Sedan, who works in my lab. I'd like to thank my lab, the CU Boulder Craft Tech Lab, the McNair at CU Boulder. And questions?
We do have a good amount of time for questions, so
okay.
Just feel free to ask anything.
Yeah.
I was wondering what kind of inspired you to do, think about visual rehabilitation with people with strokes and stuff. Like, how did you think of that idea, I guess?
So, well, I guess not recently, but back when I first thought of this device, which it's actually been in my mind for quite a bit. I'd say maybe about 1 year I've been wanting to work on something similar to this. So someone in my family had a stroke and stuff like that. Well, also, I was doing a lot of research at the time about stroke victims. And, these people, one of the difficulties that I found was that these people aren't always able to go to a specialist for rehabilitation. They aren't always able to afford it. So with this device, I would really like to program like a calisthenics program for them, just so they don't get muscle atrophy. On top of the other visual aspects that tend to be pretty helpful. So.
Would it be easier to create like a counterpart but for legs since you don't have to work examples for like moving your leg around and like walking again?
Yeah, so that's actually funny. I just read something just today on the IEE spectrum where someone used, it wasn't a similar device like this, it was basically very similar to like a TENS unit. And they had someone who was previously unable to walk about the length of a football field, I believe. And that's something I'm very interested in. One of the other things I'm interested in is trying to use this as like a GPS device. So attaching it to your thigh and then having the device steer you in a certain direction as well. Yeah.
Could you do something in real time? Let's say someone's playing the piano, and then that person's connected to it, and then the person next to them has their fingers move at the same time. Could it work that fast?
Do you mean one person's controlling the other person?
Pretty much, yeah.
Yeah, so yeah, that's actually, yeah, that's going to be way farther down the road currently. But what you're talking about is, so this is more of an EMS device. What you're talking about is more of an EMG device, which EMG device measures the potential in your muscles when they're moving. And yes, that is something that I'm very interested in looking at. But yeah, I mean, there's other ways to substitute around that, right? So like I could just be like, when the person plays the keys on their pianos, it'll activate the device and control that person's hands, which probably isn't as close to what you're thinking, but it's sort of like a
way around it.
Yeah, exactly. Yep.
So you mentioned on one of the very nice examples, the movies that you played, that you applied a little too much voltage to one of your fingers. What is a typical power output that you're aiming for?
Mm-hmm. So for me, I kind of vary just based on the muscle groups. So for that example, I was actually having a really hard time finding my index finger. So I had to turn up the voltage a little bit, which these two fingers, your ring finger and your middle finger, take up a lot of real estate. And your index is actually kind of buried almost underneath those. So I'd say typical power wattage, for me, I personally prefer like 25 milliamps, which I think that's pretty comfortable for most people, I'd say.
You mentioned about your cat and the tactile feedback device. How does that work?
Yeah, so it's actually like a little bit of a nice science experiment as well with the little cat. So the little cat, you take voltage into one side, but in this side I have like multiple like petting zones for the cat. so everything's on the up and up, just so you guys know. But I have multiple petting zones on the cat that take 5 volts. And then the other side, it goes into the analog port for the Arduino, which I use to measure the voltage. So as I said, like your body isn't a great conductor, but it can carry a current with it. So by placing your hand on the live side, the side that has the 5 voltage, you're able to carry that onto the other side and make a connection using your hands. So yeah, hopefully that answers. Yeah.
Any other questions?
What is your current voltage source, and so is your plan to potentially make it mobile?
Yeah, so currently this device, I'd say this device is a little bit wasteful just because I haven't found a use for all 32 connections. So like if I step it down and use half a relay, like let's say maybe like 5 or something, right? Then yeah, it'd be very easy because like 5 relays is probably only about this big on your arm. So it'd definitely be flexible. And as far as the voltage source, so you can choose a multitude of voltage sources. So you can use like certain EMS devices, which is like a TENS unit. You can also hook up a battery, just as long as it's DC. You can also create your own sort of DC step-up converter, which is this little thing right down here.
Have you looked into kind of neural control of this machine at all?
What do you?
Like, have you looked into like possibly like expanding this towards like brain, like having the own user's brain input into being able to control this?
Yeah, so yeah. I mean, I'm a little bit worried about that because I don't want to be too intrusive. Because like one of the main goals for this is that like anybody can just go to like a hardware store and build this. It's like the relay board. If it was on right now and you heard it, the sound isn't that much different from like a turn signal in your car. It's actually pretty much the exact same thing, right? So pretty much that would be taking it like a step further, I guess, from my current goal. But I would say yes, it's definitely possible. There are certain devices for the Arduino that I know can measure brainwaves, I think. So yeah, I think it'd definitely be possible.
We have time for possibly just one or two more questions.
Nope, I think we're good.
All right.